Recording. Is it recording? I hope it's recording.
I think so. Yeah.
It is recording. Okay, so as is customary, whenever we start a recording or whenever we start like a production, I learned this from some of my heroes in cinematography. To check voice and check whether a mic is working or not, we basically ask what you had for breakfast. Or in this case, because it's the month of Ramadan, what my friend had for suhoor. So, could you tell me?
Yes, this morning I had some chicken biryani.
Chicken biryani, nice.
Homemade from the hostess truly.
Yes. So, okay, perfect.
What did you have for breakfast?
I had... What did I have for breakfast? I forgot. I think I had a peanut butter sandwich.
Nice. Classic.
Yeah. I heard, so the place where I got this from was this guy called Brady Harron. He's an excellent interviewer and cinematographer who is responsible for all these channels called Number File, Computer File, 60 Symbols, all these periodic videos and all that. And he was interviewing Terence Tao, widely regarded as the best mathematician on the planet right now. And this was his question to him, to Terence Tao. Like, what did you have for breakfast? And Terence Tao says a jam sandwich, being the Aussie that he is.
I think it's a very, very good icebreaker.
It is, yeah.
Exactly.
Yeah. That's one of the reasons I kind of like. I like this idea that Brady wrote about. Just asking what you had for breakfast or lunch or whatever.
However, we didn't come here to talk about breakfast. We came here to talk about something else.
We did. I'm getting to it. I'm trying to make a segue to it. So, what I'm trying to say is that so Terence Tao, right?
Right.
One of the most extraordinary mathematicians out there. Probably even the best. He's regarded as the Mozart of mathematics. And his answer was a jam sandwich.
That's a bold statement. Mozart of mathematics.
Oh, many newspapers actually called him the Mozart of mathematics.
Wow.
And the thing is, he ate a jam sandwich on the day of the interview. I ate a peanut butter sandwich today. Am I half great, or is it just...
That makes you the second best mathematician.
Oh, I truly appreciate the compliments, but I can only hope and I can only dream to become the second best mathematician in the world. And also, if I'm the second best mathematician in the world, God help the world. Because
hey, if it's going to come from anywhere, it's going to come from University of Toronto, right?
Yeah. This is not sponsored by the University of Toronto.
Well, we wish it was, but
Yeah.
I guess not.
Okay, so what I'm trying to kind of point out here is that even like people who are touted as extraordinary have a very common breakfast, or they have a very common life, or like they have wives, they have kids, they have friends, they have family, you know,
Hobbies.
And, exactly.
All these things.
Yeah, all these things, and they're no different to like a regular human like us. And this is particularly, and now this is a big segue, a big jump, but this is particularly visible when you look at things in science sometimes. Even the most extraordinary molecules have some ordinary properties. They have a boiling point, they have a melting point, they have other etc. things. And this is also visible when you look at space. There are huge stars, but why are they stars? Because they follow the very common definition of stars. And why are they galaxies? They might be like a galaxy that is millions and billions times the size of the Milky Way or whatever. I don't know whether it exists, but it's still a galaxy. It's still called a galaxy. It is still that same old jam sandwich that Terence Tao had. And what makes this jam sandwich different from the peanut butter sandwich that we see using our regular telescopes is that there is a special new telescope in the sky right now. and that special telescope is the James Webb Space Telescope, and it is redefining everything. So I will bring in my friend, the astronomy major. I forgot to introduce him, but he is Samir Seif.
Hello.
And yeah, that's him. And he is an astronomy major at the University of Toronto. Both of our, I forgot the word for this. Latin is not my strong suit, and neither is interviewing as of now. But it's both of our alma mater, whatever. It is where we studied, and as you say in proper English, it's where we studied, and to be more precise, at the time of this recording, it's where we are studying, but we are going to get done soon. So, and because we want to put this behind us. University of Toronto is kind of behind us now. So yeah, it's where we studied in the past tense, and
It's quite interesting. I want to backtrack a little bit when you said we see these things in the sky called stars.
Yeah.
And we talk about the definition of a star.
Yeah.
And at the beginning of my astrophysics class, we were talking about what exactly is a star, and there were so many different interpretations, like a certain amount of helium, certain amount of mass, certain amount of this, certain amount of this, for fusion to happen. And like my professor looked at us and all went, we're in like third, fourth year of astrophysics, and he said, no, it's just a giant ball of gas. He was like, you gotta dumb it down sometimes, keep it simple. And I guess segueing away from that, we were talking about the James Webb Telescope.
Yes.
And what I think is super interesting is that there are these points called L1 and L2.
Yeah.
Yeah, like honestly, I didn't know those points existed until my second and third year at university, where the gravity of a planet and a star exists such that something can orbit in between the planet and the star, or on the far side of the planet and the star, and stay there throughout the entire year as the planet orbits the host star. I think it's super interesting how we can put something like this James Webb Space Telescope in the L2 point, so we can continuously view the night sky from the ideal perspective.
Right. And this is exactly why I brought the astronomy major on, because I'm a physics major. I understand particles, and I understand nothing else apart from that. So yes, so it's good to have an astronomy major talking about this. And so what I would like to know from you is that, so you speak about these L1 and L2 points, and there's actually one of the reasons that most of the so there are actually five such points in any given system. So say you have the Sun Earth system, there are 5 such points. There's L1, L2, L3, L4, and L5. But most of these space missions that do any sort of studying uses just the L1 and L2 points. And if you look at the Sun Earth system, it's just like if you want to study the sun, you send a mission to L1 because that's between the sun and the earth, so you can directly look at the sun while being in constant communication with the earth. For example, there are many such missions that went there, but one of the future missions from the Indian space program that I can recall right now is the Aditya mission, which is going to get launched hopefully this year. And so it's going to get placed at L1. But what the case with the JWST was that you need to get as far away from sunlight as possible. You want to study the depths of space. You don't want any sunlight interfering with your observations. You don't want any stray light or any stray heat distorting your observations. So that's why the JWST is at L2. And so going back to our astronomy major, Samir here, why do we, so now this is in hindsight, but JWST is now at L2 and it's observing the universe. What are the things that we are looking at?
So basically, when you observe far, far away places, You're basically looking back in time, which is associated with this property of space we call redshift. And basically, the idea is as light travels through the universe, it loses energy, and as it loses energy, the wavelength of that light becomes longer. And when wavelengths become longer, they move towards the red side of the spectrum, or the infrared side of the spectrum. They start out in the UV or in the gamma rays once they are emitted from a host star, and then they become more redshifted. And as they become more redshifted, they travel through space, and then they eventually reach our detectors, reach our eyes. And what the James Webb Space Telescope is doing is basically pushing the boundaries of where we can see, pushing the boundaries of the distances in space that we can see. And a lot of the observations that we're seeing aren't very expected. We're like the first glance from the James Webb Telescope is telling us that the universe is a lot older than we might have first thought. I wouldn't be able to put a solution on this problem, but I think we just need to continue to observe the data, observe what we're seeing, and maybe put an explanation onto it. Maybe the universe is older than we expected. Maybe we need to revisit some cosmology theories. But at the end of the day, I think it's very interesting what we're seeing.
I agree. I completely agree. And what people generally like in the general populace, people think that if science is proven wrong at some point, then it's game over. Whereas us scientists, we believe that wherever we are wrong or wherever a theory breaks down is a very exciting time, because then a new theory steps in or a new model of the universe steps in, and then we can explain something better. Then that model fails. Then we make an even better model, and then that model fails, and then we make an even better model, and so on and so on and so on. That's the scientific method. We make models and we make them as foolproof as possible. But if they fail, that is an indication that there is something larger at play. And when you think that there's something larger at play, that's usually an indication that there's some new physics or new astronomy to be learned.
Which is super exciting.
Which is very exciting, yeah, exactly. Yeah. And JWST is basically doing that. It is challenging our old notions of the birth of the universe. It doesn't look as far back as the birth of the universe, but it does look very close to it. And it is finding galaxies that shouldn't be there because they are not. The universe wasn't old enough, according to some of the current theories, and it's kind of pushing our understanding in that sense. I'm familiar with aviation terminology, and many of the pilots, when they take a plane up for a test flight, they say they are pushing the envelope. They are kind of pushing the envelope and hopefully not cutting through it, because they want to push the envelope and they want to test how far an aircraft can go. And this is basically JWST is basically pushing the envelope on our understanding of the universe.
Hopefully you can teach me a little bit more about that aviation lingo as I move to flight school after my undergraduate.
Congratulations on that, by the way.
Thank you.
Our astronomy major is heading for the skies literally by flying, and I'm gonna be cheering on from the ground, and hopefully I'll join flight school one day myself.
Absolutely. Maybe after my first year I'll give you a couple pointers.
Yeah.
But yeah, my ultimate goal is to become an astronaut, and I think 1 foot at a time, or I think in the metric system, 1 meter at a time. You just go up and up and further up. Soon enough, I'll be in orbit, as some of my childhood heroes have been. I just actually got the chance to see Chris Hadfield talk at the University of Toronto recently, and man, does he ever have a stage presence? He's awesome.
He is literally the literal embodiment of the word astronaut, in a way.
Totally.
And totally wowed by him. I didn't have the fortune to meet him in person, but hopefully one day. And coming back to the point that you want to become an astronaut in the future after going through flight school and all the training and all that. Now, since we were also talking about JWST, JWST is looking at like the past of the universe. It is looking at some very fundamental physics. But in the end, at the end of the story, it is just another space mission. A very expensive one, but it is just another space mission. How do you think the progress in space flight uh, has enabled us to do things like JWST, which although JWST was proposed in 1998, it was scheduled to be first launched in 2007. It launched in 2021, a good 14 years after it was actually planned to be launched, with a cost of over $10 billion.
Right.
Not a cheap mission to send to space, and we had to get that right in the first try. So how have advances in spaceflight and how have advances in human spaceflight helped JWST be flawless up till now, at least?
I think it comes down to understanding the different factors that govern what it takes to get into space. There are different factors for different missions and different requirements for different needs. Like, for example, if you were to put a human in space, you'd have to send them with food. You're not going to send dehydrated food with the James Webb Space Telescope, right?
Yeah.
So when we're talking about what it takes to get into space, there are a few different ways of looking at it. Our science has gotten better. Our understanding of orbital mechanics has gotten better. The rockets 100% have gotten better over the past few years. If we see what SpaceX is doing, super excited, especially with the missions coming up in 2024. We're going to see some astronauts go to the moon for the first time in 50 years?
50 years.
Fantastic.
Yeah.
But yeah,
52 years to be very precise. So yeah.
But yeah, what's helped us to accomplish this is to truly put some time and effort into the calculations needed to, one, put things in space, one, maintain things in space, and three, keep in touch with our things in space, like communications and just the operations that have been happening here on the ground.
Yeah. And the reason I brought this point up is that space telescope of the past, one of the most revolutionary space telescopes that we ever have had, and as of this recording, it is still in operation, called the Hubble Space Telescope.
I knew you were going to say that.
Was designed such that the space shuttle could go up and service it. So if there are any updates or upgrades necessary for the space telescope, they could do that. And it was actually necessary because there was a fault in the mirror when it was first launched. And when it was launched, there was a defect in the mirror which was very minute, but it was enough to cause the images to be very blurry. Now astronauts went up in 5 servicing missions and eventually fixed it. Like they fixed it after the very first one, but they added upgrades in the remaining 4 servicing missions, which continued, I think, until 2005 or so, and or maybe even later. But that kind of servicing is not possible for James Webb Space Telescope, and so that's why it was kind of necessary to get it right on the first try, because it is going to L2. L2 is 1.5 million kilometers away from Earth. That's about 1 million miles for those who are metrically impaired. It's sorry, we are in Canada. Canada uses metric system.
Deal with it, man.
Exactly, deal with it. I'm from India. Metric system all the way. Please right. Use meters and kilograms and seconds. Anyway, if you use feet, sure, go for it. Why not?
You said what, 1 million miles?
Approximately 1 million miles. It's less than 1 million miles, but it's close to 1 million miles. 1.5 million kilometers or 1 million miles away, you can't really send a human space flight mission that far. Also, there's a couple of reasons for that, because we haven't even sent a mission to moon for a long-term. We haven't sent a long-term space mission to moon in about 52 years. Now, the case 52 years back was that it was kind of shortly put together, and it was enough to beat the Russians to the moon, but it was not a very safe method to do so. And Apollo 13 kind of proved it to us. In fact, we are talking about this, I think this is the 53rd. I think today is the day of this recording is the 53rd anniversary of the famous or the infamous radio call, Houston, we have had a problem.
That is crazy.
Yeah,
That that is insane.
It was launched. I think it was 50. It's either the 53rd or the 52nd anniversary of this. No wait.
What's today? Today's April 13th.
April 13th. It happened on April 13th.
Nice.
Yeah. 1969 was Apollo 11 and 12, and then Apollo 13 was in 1970. So yeah, it is the 53rd anniversary of that happening. So it is the 53rd anniversary of Apollo 13, and yeah, it kind of went to show that how the program was fast tracked to beat the Russians to the moon, and safety was, although it was a concern and it was being maintained, it wasn't up to the standards that we have today. A couple of unfortunate examples have led us to improve human spaceflight over the years, and that is why we have strict standards, and that's why it's only after these 52 years that we are actually sending humans back to the moon. And like next year in 2024 we are sending humans back to the moon, and moon is like about 400,000 kilometers away from us. It's not even close to L2. So sending a human mission to L2 to repair the James Webb Space Telescope is not in our near future, at least. Good thing is the James Webb Space Telescope was put in such a precise orbit and with such an efficient trajectory that it has enough fuel to last 20 years. So if we can improve our technology and improve our mission understanding from the moon missions in these 20 years, I think we might be able to plan a servicing mission to the James Webb Space Telescope.
And it wasn't just the operations of putting the James Webb Space Telescope where it is now and making it so efficient that it can last as long as it can. It's like the steps that it needed to take, all the openings, all the gears, all of like the steps that the James Webb Space Telescope had to go through to be totally operational and as in top peak performing position performance how do I say that, performance top performance status, I guess.
Mm-hmm.
As it is now. And I think we have like everyone here on the ground to thank for that, and like we're just like super excited to see all this new data coming in, and
mm-hmm.
I can't wait for it to be publicly available and just to look through it, because I know like same thing with the Hubble Space Telescope and all the different databases that we have online. There's actually a cool thing that I've been doing on my spare time. It's like the Zooniverse.
Yes.
Zooniverse.
Galaxy Zoo.
Yes, Galaxy Zoo, and you can go and classify galaxies on your own time.
Mm-hmm.
Being an astronomy major, I'm geeking out over that.
Mm-hmm.
But yeah, is using machine learning and all like it's not even just astronomy that we're excelling in; it's also computer science, and I think those two things go hand in hand quite well. Especially with like all of the new AI and everything that's been coming out recently.
For those who are interested, just Google Zooniverse or Galaxy Zoo, and I think it should be the very first website that pops out. And yeah, you can, like, it's a citizen science project. Like, it is organized by actual scientists, but it is done by citizens, like general citizens like you and me, and anyone can do it, and it helps contribute to the statistics of galaxy evolution and galaxy shapes.
Galaxy classification,
Yeah.
galaxy evolution, and like we're obviously finding new galaxies every day, right? There's like hundreds of billions of them out there,
Mm-hmm.
and they all need to be classified at some point. So if we all put our hand on the Zooniverse, maybe it might be able to create a dent in the, probably not the dent with the numbers being as astronomically large as they are, but
Was the pun intended?
absolutely,
Yeah.
always.
So fun fact about the Zooniverse, I think if my memory serves me right, it is those images of the galaxies for Galaxy Zoo or the Zooniverse basically are taken from the Sloan Digital Sky Survey, or the SDSS, a massive survey, very massive survey, surveyed like, I don't know, millions of galaxies, or I don't know whether it was billions, but it was a large number of galaxies, and that's what people classify. And this project actually ended Like people
Yep.
finished all the galaxies that were available. Um, but there's a huge but here. Um, the James Webb Space Telescope has been taking some really, really high resolution pictures and really, really detailed pictures. And in
Have
that,
you seen some of them? Like those first ones that were released were absolutely crazy.
they were mind bending and light bending at the same time.
Nice.
And a little gravitational lensing joke for you. But yeah, they are so high definition and so highly like they have so much detail in them that you see like every single light dot there is probably a galaxy. And now we have such a huge database, or at least over the years, over the 20 years approximately that JWST will operate, we'll have such a huge database of galaxies that need classification. And see, we might be seeing a revival of the Zooniverse
Yes.
for this very thing. Now, the images in the SDSS were taken in the visible wavelengths, but the images that are taken by the James Webb Space Telescope are taken at the far visible and near infrared or far infrared ranges. So infrared visible
Yeah,
range.
which consequently actually helps us to see more galaxies, because when we're looking in the visible spectrum, there's lots of what we call dust and and particles that block out a lot of the patches in the sky. But when you look in the infrared, you can actually see through that dust and see what's behind it, and like see a lot more galaxies as a result.
Hold up. Is it the same dust as we see in our living rooms, or
No, 100%.
what is this dust?
I believe. Gotta recall from maybe pull up my notes and take a look. But I think it's just like space gas and just from, if I was to take a shot, is space gas and particles. It's not like the same particles we see in our living rooms. No.
Okay. So it's not dust or like dust mites and whatever that you need to vacuum under your carpet or you need to brush under your carpet. No, it's not that dust. So it's like it's gas. It's gas in space. But so you said infrared kind of helps us see through that. So does that mean that if I have an IR camera and or maybe like a heat-seeking camera, I can see through the dust, maybe in a tornado, for example? Can I see through that?
No, I don't believe that's the case. Oh no, it depends on what's behind the tornado, right? If there's a heat signature behind the tornado,
Yeah.
then you would be able to see what's behind it, right?
As long as it doesn't get obscured completely.
Exactly.
But the thing is, you just said it's like gas in space.
Mm-hmm.
Tornadoes generally have solid particles, though.
Mm-hmm.
It's not like pure gas. But if we had like say, like a gas, an opaque gas.
Yeah, if the gas is opaque,
Yeah.
then you definitely wouldn't be able to see through it.
For a strong enough heat signature, we should be able to see it.
It depends on how, yeah, exactly, on how strong enough the heat signature is.
Mm-hmm, mm-hmm. Right. Yeah. And I mean, in space, what's the best heat signature you can get? It's just stars behind this dust,
or a dying one,
or a dying one, exactly. And that's one of the most spectacular events you can ever see, astronomically speaking.
So spectacular that they're so short-lived, and when one happens, we just need to point all of our telescopes at that one place at one time, see if we can get a decent image of it.
And yeah, we are talking about supernova here, and not like neutron star mergers and all that. Those have been a fad recently because of the LIGO coming up about 7 years ago. Can you believe LIGO announced its detection 7 years ago?
Yeah, it's been like, oh my goodness, like these are the gravitational waves. Right?
Yeah.
That makes me feel old, honestly.
They detected it in 2015.
Yeah.
Like in November. Announced it in February 2016, and it's been 7 years now.
7 years since then. Wow.
Yeah. 7 years since the announcement.
And what? We haven't found another one since, have we?
Oh, we have found plenty. Yeah. There are plenty of papers on that. But Yeah, so gravitational wave observations and that kind of astronomy is opening up another area of astronomy which can be corroborated by other space telescopes. So, like there was this event, like the August after they first announced the gravitational waves. I think it was August 2016. This was a neutron star merger, and this emitted radiation in the visible wavelengths as well, and in gamma rays, and like over the entire electromagnetic spectrum. And basically, every single telescope in the sky turned towards it to look at it.
And like you said, it's creating a whole new branch and full circle to what we were saying before, pushing the envelope of what we understand, and creating new models in the scientific method. And I just think it's quite honestly fantastic what we're doing.
It is fantastic. And to think, this is the kind of science that we get while being on the ground. This neutron star merger detection gave the gravitational wave scientists the Nobel Prize.
Yes.
It was not the first one. It was not the very first detection. It was this one that gave them.
It was the direct detection of it.
It was of the neutron star merger, because that this could be confirmed by other sources as well, and they got the Nobel Prize for this. And I think it was, who was it? It was Kip Thorne, Barry Weiss, and one more important scientist that I'm forgetting, but I should probably remember their name.
Mm-hmm. I don't know it, so like kudos to you for knowing the first.
Yeah. But yeah. Now, since James Webb Space Telescope is up in the sky, it can kind of help us do these kinds of observations as well to corroborate neutron star mergers and all that. And yeah, it is possible that neutron star mergers emit not so heavily in the infrared, so maybe the James Webb Space Telescope doesn't have too much to look at, but it might be something to look at. Now, James Webb Space Telescope is not just doing like deep sky images, or it's not just looking at galaxies. It is also looking at some things that are very close to us, and those are planets, and like the rings of planets, for example. And one of the latest images that was released was of Uranus, and despite the hilarious naming of that planet, the rings look absolutely gorgeous, as does any picture from James Webb Space Telescope.
You know, the naming of that planet, I think you told me last time, the naming of that planet is quite hilarious back in history as it is now.
Mm-hmm.
And that planet was almost named George, which, imagine that. Mercury, Venus, Earth, Mars, Jupiter, Saturn, George.
Yeah.
But yes, I'm actually taking a look now. Are these the names we're looking for?
Yes. Oh, it was Barry Barish, not Rainer. It is Rainer Weiss, Barry Barish, and Kip Thorne.
Nice.
Yes. A quick search on the internet, and you can avoid the gaffe that I just made.
We've got to give credit where credit's due, right? This is a Nobel Prize.
Yeah, it is a Nobel Prize. And fun fact about Kip Thorne, he worked on the movie Interstellar. Like, he was one of the executive producers.
Which makes sense why it's so accurate.
It is very accurate. In fact, even the visuals were done using the math that he did. And the visuals are so accurate that they actually wrote papers on that.
That's quite interesting.
Let me specify. Papers, multiple papers on that. And it was just awesome. Yeah. So, the James Webb Space Telescope, it is a gold-plated, 18-mirrored space telescope. Gold-plated, but layered with beryllium to, I guess, preserve the gold. And you know what the fun fact about that is?
What's that?
All of the gold that is on the James Webb Space Telescope, if you were to lump it up in a ball, it would be the size of a golf ball.
And the fact that the James Webb Space Telescope has the diameter of what? How large is it?
Approximately 6.5 meters.
That means the gold is like what, a millimeter in thickness? It's like super thin layer of gold on it.
It is, yeah.
Super precise.
It is. I mean, gold is definitely one of the most malleable metals out there, and
doesn't rust. doesn't erode. Well, obviously, it wouldn't like metal probably wouldn't erode.
Yeah.
Regardless, in space, but gold alloys being probably the most durable that we've seen.
Yeah.
In the vacuum of space by itself, at least.
Yep. But there's one big reason why gold is used and not, say, aluminum that was used in the Hubble Space Telescope. It's because gold is an excellent reflector of infrared light. Aluminum is an excellent reflector of visible light. That's why it's used on the Hubble Space Telescope for like observations in the UV and the visible range. But for the JWST, since it's looking at red and infrared wavelengths, the best reflector in that range is gold, and that's why they're using gold. It's not for like making it look fancy or anything, and it certainly.
Well, it definitely is fancy.
It is definitely fancy, but yeah, to those people who think the gold cost a certain fraction of that 10 billion,
no,
I can assure you it was not that much of a that big of a fraction.
Maybe the process of like putting it on the way it's meant to, probably costs more than the gold itself.
I agree.
Let's see. We've been going for how long now? About 30 minutes in.
Mm-hmm.
Make sure you guys put some comments down. Like, ask your questions about astronomy. Maybe we can get back to you with a part 2, coming back and answering your questions. Like the video, subscribe.
Mm-hmm. And yeah.
What else can we talk about in regards to space? I know we're both University of Toronto soon-to-be alumni. We should be able to pull something out. We could talk about Jeremy Hansen and his soon-to-be endeavors on the moon.
Yeah.
They're not landing.
They're not landing, but it is still historic. I actually wanted to talk about a couple of mutual friends of ours, who are working with actual JWST data as part of their research projects for their final year. And I'll not name them, but they are very close friends of ours, and they were working with actual JWST data, and honestly that was so cool because they had access to images that were going to be released to the public the next week, a week before it was released to the public. Like approximately, like I don't have the exact timeline on that, but they had access to images that were not released to the public.
And yeah, that was once they were released, we got a good look at them. But that was honestly like super cool for them to have a sneak peek at the data.
And because I'm not taking their names, but I will like to identify them using their kind of nicknames. So it's. One of them is a very famous character from Star Wars, one who is known for having the higher ground, and the other person is I don't know whether she was actually working with GWS. No, wait, she was.
Obi-Wan and
Obi-Wan's friend.
Yes.
So so Obi-Wan and Obi-Wan's friend. So shout out to Obi-Wan and Obi-Wan's friend.
We'll call her Kenobi. Obi-Wan and Kenobi.
Obi-Wan and Kenobi. So yeah.
Nice.
Obi-Wan and Kenobi. Yeah. So hey Obi-Wan, hey Kenobi.
Make sure to like, subscribe.
Yeah.
Maybe we'll get you guys on the next episode.
You know what? I'll name this podcast or name this video The Higher Ground to make sure that you come here. So
nice.
There are enough Star Wars jokes that can be made. We made them throughout the 4 years that we were here with them, and honestly, we're not done.
Yes, here's one more at least.
Yeah.
So maybe let's shift gears. We can talk. We've been talking about space for a while, but let's talk about one of your passions. I know you're quite the photographer.
Still learning.
Yeah.
But I mean, a good photographer, or anyone who wants to become good at something, they need to be a student, not a teacher.
Like he's being too humble, guys. Don't even listen to him. Like throw your Instagram handle for your photography page. You guys should check him out.
I will. It's @photo_mish, then 21.
That'll definitely be in the description.
It'll be in the description. In fact, I'm planning to actually put this YouTube page on my Instagram handle as well.
Nice.
Once I have 1,000 followers on Instagram, currently at 850. So
getting there.
Yeah, getting there. Need 150 more, which would take me around a year or so. Yeah, I'm kidding. It takes me around.
I know there's a lot of aviation nerds out there, so you guys will be able to
aviation, yeah, and
aviation pictures.
Fun, like very fundamental connection between aviation and spaceflight. A lot of the astronauts were pilots.
This is why I'm becoming a pilot.
In fact, yeah,
this is the main reason.
Yeah,
why I'm becoming a pilot.
Exactly. That's why Samir is going to flight school, so that he has flight hours under his belt, flight experience, and then he goes. Then he can apply to become an astronaut. Now, yeah. So I have some pretty massive spectacles, and while I do intend to get them corrected using a laser operation soon, I do think that, like, as of now, flying school is not in my cards. Maybe later in my life, but now it's not on my cards. And because it's not on my cards, the one way I enjoy aviation is by going to the airport and clicking pictures. And I found that, like, these marvelous bodies that just float through the air, the glide and the roar of their engines, and like it's almost poetic. And we know, like, it's a common phrase that a picture tells 1,000 words, but I think if it is poetry, 1,000 words is probably not enough.
Yeah.
So I just click pictures on burst mode and just
hey, the quality of your pictures, like, they don't represent 1,000 words, they represent 1,000 stories. Like, honestly.
Thank you. That's honestly the goal of any photographer, I think, because any photo that you click needs to convey what was going on in your brain, what was going on in the subject's brain, what was going on in the environment, what was the era that this photo was taken. Some of the best photos that were ever taken in history, which are known, which are historical photos, they have survived this long because they are good photos and because they convey what is actually happening. In fact, just before this conversation, we were talking about a photo that I had seen in one of my history textbooks. It was a photo of Germany. I think this was right before World War II. And this was when the German currency, the mark, had lost value, like, tremendously. And what people had to do then was to literally get a truckload full of money, just of cash, to buy a loaf of bread. Just a loaf of bread, 12 slices, 13 slices. They had to get a truckload of money and get that. And that picture was there in my history textbook, and I still remember it because it was such an iconic picture. It told the story of the time, how the German population was suffering, either before the Nazi regime and during the Nazi regime as well.
Might as well carry around a money printer with you. And
yeah. But you probably need like 2 truckloads to buy the printer or something. But yeah. So that kind of photography, that really, really inspires me. And because I like, and sorry, I should correct myself. Because I love aviation, I pursue aviation photography as a hobby.
Yeah. And there was that one thing that we got recently. It was the Apollo Remastered. I'm actually looking at it right now.
Yes.
It was like we were talking about iconic photos, and that book is full of them.
So, Mr. Andy Saunders, you are an absolute genius. Honestly, you are an absolute genius.
Honest to God, man.
The astronaut took the photos, but the way you have restored them, photos from like 50 years ago, like complete change in technology.
Of the crispest, like the most crisp resolution, the final images are like absolutely astonishing.
They are more resolved than like photos that you take from digital cameras and see it on your laptop. A laptop cannot do justice, or a desktop cannot, even a projector screen or even a theater screen cannot do justice to these images. You have to see them on the book, like in print, in of the highest quality possible. And
Yeah, very recommend.
yeah,
Get that.
yeah, I got it. Like I literally bought it for myself because like I didn't want to let this book go,
Yeah.
and now it's a highlight of my bookshelf. It's also the largest book on my bookshelf, so it
Yeah.
is also the highlight in that regard. But uh, it is large because it has some larger than life photos in it. But yeah, aviation is a hobby, and through aviation, I got a taste of spaceflight and a love for spaceflight. And because I pursue aviation photography as a hobby, I hope to pursue spaceflight photography as a hobby as well. And some of the leaders in this field include like John Krause, Trevor Malman, Eric Kuna, and all the other guys. And uh, yeah, they're like absolutely awesome photographers.
Yeah, it's like talking
And
about space flight photography is like I don't know if you can get much better than the pictures taken from space. And I just went and saw Julie Payet at her.
you lucky bastard.
Yeah. Her,
He met her for the second time, by the way.
First time was at Sarah Seeger's
Yeah.
astronomy talk.
Yeah, Sarah Seeger was one of the speakers there, but yeah, it was organized by ASX.
Which
I
is
think
the Astronomy Student Union. No,
not the astronomy. Apologies, ASX, but ASX at U of T, they organized this event, and there were a couple of speakers, but I had specifically gone for Sarah Seeger, and I had dragged like every possible person that I could find to come to this event, and luckily Samir agreed to come with me, and
it was a fantastic talk. And
it was an excellent talk. Yeah, but Samir, so get up to the point to the end of Sarah Seeger's talk, because then I'm going to speak.
Yeah. Okay.
What exactly happened after that?
There was a point in the talk where someone asked Sarah Seeger, if we were to launch rockets from Canada, where would they launch from? And this random woman in the crowd, wearing a Canadian Space Agency jacket, yells out Nova Scotia. And Sarah Seeger points to this woman and says, yes, fantastic answer. We'd probably launch from Nova Scotia over the Atlantic Ocean. I noticed this woman wearing a Canadian Space Agency sweater, and I'm like, damn, that's cool. I wonder where she got it. Later on, Shri and I wanted to go talk to Sarah Seeger, so we went down after the talk and was saying hi to Sarah Seeger and all. Lo and behold, Julie Payet, Madame Payet, comes up and introduces herself to Sarah Seeger, says hello, and I realized this is the woman that was wearing the Canadian Space Agency sweater. I didn't even realize it was Julie Payet at the time. So I was asking her about...
Let me take it from here.
Because... Yeah, go ahead.
Okay. I'm glad. As a photographer, sometimes you capture the photos of a generation. And I think I've captured the best photo of Samir talking to a person, not realizing who it was.
Yeah.
Completely unaware of who this person is. And like... Samir, being the gentleman that he was talking to her very politely, but when he got to know that the person that he was talking to was actually an astronaut,
my eyes must have...
His eyes exploded, his mouth exploded. Yeah. He became a monkey, to be very frank. What?
Honestly.
Oh my! I was in shock. Everyone was in shock there. I think only Sarah Seeger knew, in that small little group of 10, 15 people who were asking Sarah Seeger questions, Dr. Sarah Seeger questions. And yeah.
But yeah.
I was there to fanboy over Sarah Seeger. I love her research. I absolutely love her research. I had been to her talk in August and attended this talk in February again. But yeah, I was there to fanboy over Sarah Seeger. But as soon as Julie Payet announced, so Samir was basically okay. So Samir's talking to her, I really like your jacket and all that. It's from the Canadian Space Agency.
And I'm asking her about her time at the Canadian Space Agency. I'm like, I want to be an astronaut. I'm telling her I want to be an astronaut, right?
Yeah.
And I go, oh, so what position are you at the Canadian Space Agency? What do you do? And then she just introduces herself. I'm Julie Paya, and I'm an astronaut as well.
Mic drop.
Yeah.
Absolute mic drop.
And I was honestly starstruck to not have realized that it was her. And like I was like a kid in a candy store getting an autograph, getting a picture, and all this nice stuff. But yeah, and truly a great honor to meet her. And I was fortunate enough to actually meet her a second time, which was at her.
Let me re-emphasize, you lucky bastard.
Yeah. I went to a colloquium talk at the University of Toronto Mississauga campus, given by Dr. Barbara Sherwood Lawler. She is a renowned astrobiologist, and she works on 2 billion year old water that is basically in the subsurface of Earth, and we're using it as an analog to possibly find subsurface water on Mars when we do go there, which would be a fantastic, revolutionary discovery, and possibly the next steps to finding life on a different celestial body besides Earth. But yeah, regardless, I went to her talk, and she is probably one of the best mentors I've ever met. She invited me to come talk again with Julie Paya at science at Massey, the Massey College, which is an extension of the University of Toronto, which works with a whole range of fantastic graduate students from a variety of different STEM fields. And Julie Paya, coming full circle, she showed us a whole bunch of iconic pictures she took from the ISS and from the
Space shuttle.
from the space shuttle, and those were super cool to see. And I just got to talk with her about her experiences in space, and what made me happy is that she said, "Oh, you're much too young to be an astronaut," which made me feel like I have time to become one. She said astronauts are usually selected within their early to mid 30s. So, and I'm 23. So going through flight school and then just make myself physically available to be an astronaut, I think these are the next steps I need to take.
And I think you're on the right track, because
Thank you. Thanks a lot.
And yeah, I think you have the mental capacity to become an astronaut. Not that like you have to learn a lot or whatever. That capacity is there. I mean, any good student can become an astronaut, but by mental capacity I mean like the correct mental attitude towards things.
Thank you.
Not being too negative about things, and taking the positive, like looking at the things and being of the mind that it can be looked at in a way, like a glass half full, not a glass half empty way, and basically being an optimist.
And like, yeah, we were talking about before about what it takes to get into space, and I said that you're not going to send dehydrated food with a robot to space to do its job.
Mm-hmm.
But when we were talking about the factors of what it truly takes to get into space, there's not just a physical aspect or biological aspect, but there's a psychological aspect of it, and there's a lot of psychological training that goes into making sure you're not going to become too claustrophobic, or you're going to be able to work with the people that you meet up in the ISS, because you're going to be up there for like 6 months, right? In basically a tin can floating around the planet. So, I mean, like, that does monumental injustice to the International Space Station. The International Space Station is not just a tin can; it's a floating laboratory. But anyways, yeah, there's a lot of psychological training and brain power that goes into becoming an astronaut as well.
Right. So let me ask you this question. So since you have already met Julie Payette a couple of times, you have seen Chris Hadfield at a talk. Who do you like? No, I'm not restricting you to these two people, but who do you think is your hero? Who do you look up to? That like, who is your role model basically, and who would you like to meet one day and just chat with them about what they do?
Oh, come on. You didn't restrict me to them, but I've got to choose Chris Hadfield.
Mm-hmm.
Don't get me wrong, Julie Payette. is like I've like meeting her was an absolute honor. And honestly, if I could sit down with her again, I would do it as many times as I possibly could, because she knows, like, being like the previous Governor General of Canada, and like she's just got so much experience doing things around the world. Um, but yeah, Chris Hadfield truly embodies the type of person I want to be. Fame wise, like he's an author now. He expresses himself, and he knows exactly how to encapsulate a crowd and tell them exactly how to improve on their own human being. Um, like at the 150 gala, the engineering gala that I went to at University of Toronto, he spoke, like if you've seen on YouTube his TED Talk, he spoke on par, if not more naturally than he did at his tech talk, and it just blew me away how amazing and how knowledgeable he is.
Well, I mean, uh, to be very honest, he's a flight test engineer, and where else would he be comfortable than in the company of engineers?
Exactly.
And I guess that's why he was probably more comfortable talking to you guys.
Yeah. Kudos to the University of Toronto engineering community as well. They've got some school spirit that I've never seen before. At the engineering gala, they had some traditions, like with the whole cannons and the basically the trophy cases of the engineering community. It was super nice to see. But yeah, role model wise, I think Chris Hadfield is definitely up there. But I have many heroes.
Name one.
I was gonna say Elon Musk.
Mm-hmm.
He's definitely up there.
Mm-hmm.
It's an old name, but there's a YouTuber. If you just maybe after this video go to the search bar and look up KSI LGBT. He goes by KSI now, but he has a crazy upbringing that I think is super inspirational. I've been watching him since 2012, so he's one of my heroes as well. Iman Gaji, fantastic businessman, fantastic entrepreneur, and I think he's one of my heroes as well. I'd love to get these, like, I've always thought about if I was to get into a room with a group of people and who I would sit down and actually talk to. I think, just to name the top 5, would probably be Chris Hadfield, KSI, Iman Gaji, Neil deGrasse Tyson, and Elon Musk. These 5 people, I think, are truly inspirational and I look up to.
What if you had... Suppose we bring back Neil Armstrong from the dead.
Oh my goodness. He's got to be in there as well.
Yeah.
Yeah, 100%.
I assume so. But yeah. But yeah, it's good to have these personal heroes, because sometimes when things are not going the right way, or even if they are going the right way but you don't think they are going the right way, or things are going hard, it's useful to remember what exactly what would a person like your role model do in that situation. Would they be an optimist? Would they be a practical person? How would they go about solving the problem that you have on your hand? And that kind of gives you a perspective that, hey, by the way, this problem may not be just special to me. It may be a problem that everyone faces and everyone gets through, and maybe I can learn from them and get through that problem. And I guess role models help that way. I have certain role models in my life as well, and I rely on them to give me inspiration in a way. And that, yeah, they, dead or alive, they do inspire me all the time to pursue and chase success, or chase excellence outside my comfort zone. Because inside my comfort zone, I can be the smartest man in the room, but if you're the smartest man in the room, you're in the wrong room, as has been said multiple times.
That's a fantastic saying.
So yeah,
why don't you go ahead and name a few of them though?
Like my role models?
Yeah.
I'll go with a classic example. I'll say my dad, just for the discipline that he instills in me.
In just for the record, his dad is actually super cool.
Thank you. So, hi Papa. It's just yeah, I think the discipline that he instills in both me and my sister, and the way he has raised us. So my mother is very caring and very generous, and my dad helps us keep helps keep us grounded, and in a way, it's kind of like a balancing act. Sometimes my dad is more generous and my mom is more strict, and sometimes my dad is more strict and my mom is more generous. It is a balancing act between those two. So I think my parents are my role models.
And like with that respect in mind, I feel like I want to follow in your father's footsteps as well because he's a pilot.
He is a pilot. Yes, yes. Um, I hope to bring my dad onto this YouTube channel one day. Uh, that would be one hell of an interview. Um, and it's yeah, but yeah, I would love to talk to him. And coming back to what Samir said, like if you had all your role models in one room, that's actually a nice place to be in, because then you can just learn from everyone. And I think having my role model as my parents uh, gives me good access to them. So
Yeah, like
daily inspiration by
I think respect should be given where respect is due, and
Mhm.
and like the sacrifices our family makes for us on a daily basis, and maybe stuff we don't see in the past are very important to take into account, even if you don't know the sacrifices that have been made in the past. And I think um, I'd like to give some respect to my family as well. There have been tons of sacrifices, years of work to get my family where it is today, and I just want to say thank you to my family for pushing as hard as they can to give me the life that I have today. Subhanallah, thank you for all of that.
Fun fact: Samir's mother is a photographer,
She is.
and
She takes pictures
she's
of
one of
birds.
the most talented photographers I've ever met. And I am an amateur photographer, but like, uh, and like, if say I were to play Roger Federer tomorrow at tennis, I would know that I am amateur and he's pro. It's the same way that when I look at the pictures that his mom takes, I feel like I am completely outclassed here, and there's so much to learn from her.
She's got some experiences doing wedding events, and she takes pictures on her free time as well as um, she used to do it for her career as well. So she's got some experience. She could give you a pointer or two, but your pictures are already like, in their own respect, fantastic, dude.
Thank you.
Yeah. Don't even like take yourself for granted there.
She likes to take pictures of natural birds. I like to take pictures of metallic birds. But yeah. But yeah, some of the other role models. Actually, uh, a slight tangent here, but there's this like a. It's called a shlok. It's like a two-line um, poem in a way in Sanskrit. It's I guess it's kind of a prayer. It's not a prayer. It's like a moral of a story in a way.
Right.
Anyway, I'll just say it. It goes like Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Param Brahma, Tasmai Shri Guru Dev Namaha, which translates to that is Brahma is a god, and he's my guru or my teacher. Vishnu is a god, and he's my guru or teacher and a god. Shiva is a god, and he's also my teacher. But if God were to come in person to meet me, and my teacher was also sitting next to him, and I had to choose who I bow my head down to first, I would bow my head down to my teacher, because through my teacher I could get access to the God.
Interesting.
That's kind of the perspective. So in like Hinduism, we treat teachers on on the same level as gods, I think. And I think I've had some fortunate experiences with many teachers in my life, and many of them were responsible for instilling a love of physics in me. So Miss Lindsay Benny, thank you very much. Like, I am where I am because you instilled a love of physics in me back in grade 10. And Mr. Rajiv Sinha. Again, you showed me how to do actual physics in grade 12, and you're probably one of the most smartest physicists I've ever met. And who else?
We can go
Yeah, we have so many teachers to name.
pretty long with these lists of teachers, especially the
Yeah.
ones that we actually haven't met. Like, for
Yeah.
example, we have a couple textbooks
Mm-hmm.
from a good man named Feynman. He's
Yes.
he is a fantastic teacher, and we didn't even meet him. We could go on Stephen Hawking. We have books from him as well, and these can be considered teachers
Mm-hmm.
that instill a love of physics in all of us.
It is. Yeah. So yeah, teachers, role models, parents, role models. But since Samir took some specific examples, I'll name a couple of examples as well. So role models. Okay, yeah. There are so many. Who do I even name? I think that's actually a tough question to answer.
You being a physics major, you could probably fit Feynman in your top 5, right?
Feynman for his teaching,
Carl Sagan,
Carl Sagan for his communication, science communication.
right?
Feynman also for his science communication, but more so for his teaching, the way he taught stuff.
Right.
So that's physics. Maybe I think there's this guy called Destin Sandlin from the YouTube channel Smarter Every Day. That he has been the biggest inspiration behind me setting up this YouTube channel. Go check out his channel. You will become smarter every day. Every day that you watch his videos, and the man is like great father, great husband, and great science educator. Like absolutely, absolute rockstar in all respects. He hangs out with astronauts. Speaking of astronauts that he hangs out with, one of his good friends is astronaut Don Pettit, and Don Pettit is my role model in photography. Honestly, the best photographer astronaut that has ever lived. Andy Saunders took some pictures from 50 years ago and remastered them to become the masterpieces that they are. But Don Pettit, astronaut Don Pettit, takes masterpieces on his own, edits them on his own, and like posts them on his Instagram and his Facebook and Twitter and everywhere else. And he is he is a very experienced astronaut, but he is also like one of the best photographers who is also an astronaut. Sorry, I should he's an astronaut first and then a photographer, but his skill in photography is unparalleled.
Hey, you know, Julie Pyatt said they get trained in photography. You have to be a trained photographer to go to the ISS.
Yeah.
Like, you're not allowed to take pictures from the cupola if they're not like meaningful pictures, or if they're like actually good pictures.
That's true. I mean, you're
You
using
probably take
cameras.
some like funny selfies and stuff, but
Yeah.
like some of the pictures that she showed us when I went to Massey College,
Mhm.
they were like phenomenal pictures. And one I can remember in particular was when the tail of when the tail of the shuttle came in line with the line of light from a sunrise or a sunset, one of the two. It was quite a fantastic picture that she took.
Now, you say that they are trained on photography. I say photography is more of an acquired skill rather than something that you can train or drill into a person. They sure learn how to use a camera.
Yeah.
But I think the skill in photography comes from within themselves, from
right.
their own creativity. And I think Don Pettit is very, very creative. Even other astronauts credit him for being one of the best photographers / astronauts that are there. And fun fact, he is one of the Artemis astronauts. He's on the roster. He might get a moon mission soon, and he has been training other astronauts as well. So I really hope Don Pettit takes the camera and goes to the moon, because honestly, that would be the best day for photography, for space photography. And like, yeah, Don Pettit, one of my heroes. Chris Hadfield, again, yes. But yeah,
The best space musician.
Best space musician, yes. That is true. Best space photographer, Don Pettit. Best space musician, Chris Hadfield. And there are other firsts as well, but yeah, space is vast, and talking about space is also vast.
I think it was nice, middle of exam season, to sit down and just talk about some of our passions.
Yeah, just ignore all the exams that we have and just, yeah,
that's fair.
sit down at, what is it, 3:45 in the morning and just chat about things that we love. And yeah, sometimes it's good to remind ourselves of what we love and what we are doing, what we are in this world for our family, for our passions, for our jobs, and for I say a future family. We are young bachelors. We'll have a family soon, maybe 5 to 6 years or 5 to 6 years or so, or before that or later. But we'll soon have a family, and it's good to realize what you love in this world. And when your family comes about, when your next, like your new family, your spouse and your kids come along, then they become your priority. So for now, till the time that I'm married, until the time I get married, or until the time Samir gets married, I think both of us would look to pursue our passions to the fullest. And
even beyond that, you get married, you can still
exactly with a supportive spouse, we can just push that and then make it a common goal for
push the envelope, right?
Yeah, push the envelope, exactly. And with your supportive spouse, you can just push the boundaries like no one else. And yeah, with that, I guess we can call it an end to this.
Yeah, we can conclude. Make sure you throw some comments on what kind of topics you want to hear from Obi-Wan and Kenobi.
Obi-Wan and Kenobi. Yeah, I'll try to get them on this as well. And I have big plans for this YouTube channel. I intend to talk to some of the most famous personalities in space and in aviation. And honestly, I have some big plans. The year is 2023. Next year, there's a lot of things that are going to happen. Lot of historic things that are going to happen. And
we're on the forefront. We're going to witness it all.
Yeah. A family friend of mine once told me that do not be at the cutting edge, be the cutting edge. And I intend to do so, and I am pretty sure Samir intends to do so.
That. Yeah, 100%.
And we'll till the next time that I meet you guys, be the cutting edge. Don't be at the cutting edge. And sayonara. Good night from Toronto.
Ad Astra.
Ad Astra per Aspera.